Hi, this is Mrs. Tellas. We're going to be starting chapter 2 today. We're going to solve, graph, and apply inequalities in one variable, which just means we'll have inequality signs instead of equal signs, and then it'll just be one variable in the inequality, like x or a or whatever. So this is what inequalities look like when they're solved. They have a letter in the front, they have an inequality symbol, and they have a number. We graph those by putting an open or closed circle on a number line, and we shade whichever direction it tells us to. So this one says x is less than 2, so it's an open circle on 2, and I shade where the numbers are smaller than 2. This one says x is greater than 2, so I do an open circle on 2 and shade to the right where the numbers are bigger than 2. And then I hope you see a pattern that the two that don't have the equal sign are open, and the two that do have the equal sign are called closed circles, where you just color them in. And then the shading is the same. Left then, you shade to the left, or where the numbers are smaller than the number, and greater than, you shade to the right, where the numbers are larger than the number. Okay, so let's graph a few together. So because this says x is greater than -5, I'm going to put -5 right in the center of my picture or of my number line. It's going to be an open circle, and I'm going to shade to the right because that's where all the numbers that are bigger than -5 are. So on the right side of -5 is -4, and on the left side is -6. So if you can just put a number on the left and the right of the number that's showing in the inequality, that would be sufficient for your number line. Okay, let's look at the next one. So it says x is greater than or equal to 0. So I'm going to put 0 right in the center. 1 is bigger, -1 is smaller. It's going to be a closed circle. And the reason it's a closed circle is because it's got this equal to right here. And then we could shade to the right because it's also greater than. Notice that I color in that arrow. What that means is that 0 is a part of the solution because it's closed. 1 is, 2 is, 3 is, 4 is, a million is. Everything bigger than 0, including 0, is a part of the solution. Okay, and then sometimes when we solve, we end up with a letter in the back or the variable in the right side of the equation. We don't want that. So if we end up this way, we're going to have to switch everything. So we're going to put x in the front and 6 in the back, switch their positions, and less than is going to become greater than. So I'm putting a 6 here. It's an open circle. 7's bigger, 5's smaller, and I'm shading to the right again because it's greater than. Okay, and then down here, this last one, I'm going to switch their positions again. I'm going to switch the inequality symbol to be greater than equal to instead of less than equal to. So in the center is -2, bigger is -1, smaller is -3. It's closed. And again, I'm shading to the right and coloring in that arrow, signifying that it's all the numbers bigger than -2. Okay, so now I'm going to do a little solving. These are just one step. So when I add or subtract, I want to get y by itself just like normal. So I'm going to subtract 8 on both sides. Y is going to drop down by itself. The 8's cross out. Inequality drops, and that's -3. So I would put -3 in the center because that's the number showing in the inequality. Higher is -2 and lower is -4. It's closed, and I'm shading to the left to show that all the numbers, including -3, that are smaller than -3 are part of this solution in this inequality. So here I've got a decimal, so I would subtract 1.4 on both sides. That's -9.4. Greater than drops down, and those cross out. But the problem here is that m is in the back side or the right side of the equation, so I have to switch everything. So m and -9.4 are going to switch spots, and less than is going to become greater than. So -9.4. So we'll go -8.4 and -10.4. All right, it is open, and we are going to shade to the right because it's greater than. All the numbers bigger than that, not including 9.4 negative. Okay, number 3, we're just going to solve here. I'm going to cross out this graph because I think you've got the graph down. So we'll just do some solving. So this is going to be right here. These are like terms on the same side, so I need to combine them. So x plus 5 is greater than -16. So I would subtract 5 on both sides. And this is my solution. X is greater than negative 21. Here we have a fraction. So we need to combine these two fractions because they're still constants because they don't have a variable attached. So I'm going to use my calculator. 1/2 minus 4/5 is negative 3/10. Oops, trying to write with the highlighter. So I'm going to add 3/10 to both sides. Those cancel. X drops, less than drops. So, and again, I'm going to stick this in my calculator. 8 9s and 3/10 gives me negative 53/90. That's not a very nice inequality answer, but that's the answer. Okay, so if you want to pause and copy this down, if you're virtual, that's a really good idea because you're allowed to use this graphic organizer on your notes. If you're in class, I'm going to give you one. So I will also put the PDF of just this on the assignment for this. It's going to be a worksheet, so I'll put it on there too if you would rather have the PDF and you have a printer. Great. But you're allowed to use this on your assessments. Whoop, too far. All right, so we've got some story problems now. So this is where we're going to apply our inequality knowledge. So it says the restaurant can seat at most 172 people. So the restaurant can seat is the part we don't know. 172 is the most that they can seat. So that's going to be less than or equal to. And if I'm not sure what at most is, I go back here and look. And is at most is right here. So I know that it's less than equal to if I'm not sure. But I can also reason it out because they can't seat 173 people. That's too many. 172 is the most they can seat. Now they can seat 160, which kind of takes care of that less than. So let's go down here. It says a person must be at least, there's our inequality words, 35 years old to be elected president of the U.S. So X and 35 are there. And you have to be 35 or older. So that's greater than equal to. Because you can be 35 and be president, but you can also be a number bigger than 35. So this is our inequality. And again, if I'm not sure, I go back and look, and here's at least right there. So we know that it's greater than equal to. So we can use that graphic organizer, or we can use our brain power, up to you. Okay, here's another story problem. So it says a circuit overloads at 1,800 watts of electricity. So this is, it overloads at that amount. So if you get that number or 1801, 1802, the circuit is going to overload. Okay, they're kind of talking about a wall plug-in, I think. You plug a microwave in that uses 1,100 watts into the circuit. Okay, we're going to write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. So the microwave already has 1,100 used watts, plus some more. The some more is the X, and the most we can have is 1,800. So it looks like it's going to be less than because it overloads at 1,800. So as soon as you hit 1,800, it's going to shut off. Okay, so if we solve this, we would subtract. So X is less than 700. So you could plug anything in to this outlet that is 700 or less. So clock radio would work, blender would work, toaster would work, but hot plate is more than 700. So your hot plate would send the circuit breaker overloaded. So you wouldn't be able to plug the hot plate in there. So you would just take these numbers and plug them in and see if they're true. Okay, 50 smaller. 300 smaller, 1200 is not smaller. Okay, so that one doesn't work, and 80 smaller. So any of the other three would work. Okay, so here's the last part of the lesson. So if you have an inequality that you are solving and you have to multiply or divide by a negative number on both sides, you have to switch the inequality. Okay, and I'm going to do some examples, but press pause and write that down, okay, because it's important. We're going to use it for the rest of this unit, for unit 2. Okay, so if we do some of these problems, we want G alone in the front. So this has got a line here. So we're going to, says divide, so we're going to multiply by -3. Notice how I'm writing the -3 on both sides of the inequality. That means because it's negative, I have to switch less than to greater than. And then over here, it's -36. And again, we're not going to graph these just to save time, but I believe you have to graph them on your worksheet. I think you've got it from the beginning of the lesson. Okay, same thing here. So I want to do D. I want D alone, so I want to get rid of -3/4. So I multiply by the reciprocal. Okay, all of this cancels and D drops. Now, see how I wrote negative on both sides of the inequality? That tells me I have to flip the inequality. So it was greater than equal to, I make it less than equal to. So that would be -8. Okay, and again, you could just put that right in your calculator. Okay, so I've got write, solve, and graph. We're just going to write and solve. We're not going to graph. So 4/5 of a number is at most 20. So 4/5 of a number, just x, is at most is less than equal to and 20. And again, you could use your graphic organizer here. So there's the inequality, and now I'm going to solve it. So I'm multiplying by the reciprocal. Notice that I'm multiplying by the 4/5 reciprocal because I want x alone, and the only way to cross this out is by multiplying by the reciprocal. There's no switch because what I wrote on both sides, the times 5/4, is a positive 5/4. So let's see, that'd be 25. Okay, and then down here, 136 is less than -8 times a number. Okay, so there's my inequality, and now to solve it, I would have to divide by -8. Again, notice that I have divided by a negative on both sides of the inequality. That means I have to switch the sign to greater than. So over here, these cancel and x drops, and 136 divided by 8 is -17. Okay, the problem here, and I hope you see it, is that x is at the back. It needs to be at the front, so we're going to switch it around. So it was greater than, now it's again less than. So this is the answer I'd be looking for on an assessment or on your homework. Okay, a little bit more fraction work. I'd like you to press pause and try both of these. On the last quiz we took, the ones that we missed was the fraction stuff. So let's make sure we know how to do the fraction stuff and open up Desmos, use Desmos to come up with their products. So here I'm going to multiply both sides by 7/15. Because that's the reciprocal of the one that I want to cross out. So C drops. There's no flip because what I wrote on both sides, what I'm multiplying by, is positive. So I'm just going to do some canceling. So that gives me greater than -1/10. Okay, same thing here. I'm going to multiply both sides by -1/8 reciprocal. Okay, and again, the reason I'm doing it by that number is because the 1/8 negative is what I want to cross out, because I want x alone. Now, I do have to switch less than to greater than because I multiplied both sides by a negative. And since I did that, that makes me switch the inequality sign to greater than. And let's see, so that'd be a 1 and that'd be a 2. So this is -6. Okay, and again, feel free to put that in your calculator. Okay, I think these are the last two. So on this one, there was one like this on the quiz as well. Everybody didn't get this. So let's make sure we understand. So we want this x alone. They're multiplied. So I'm going to divide by 2. Okay, on this side, it cancels. There's no switch because 2 is positive. Okay, and then I can put this in my calculator. -6/7 divided by 2. So let's do that. -6/7 divided by 2 is -3/7. And I hope you're like, oh no, the x is at the back. So I have to switch it. So x is going to go to the front, -3/7 in the back, and greater than becomes less than. This is my final answer. Last one. It's a story problem. Okay, this is an old question. You're going to see. Text messages cost 15 cents each. You can spend no more than $10, write an inequality to represent the situation, and then you have to solve it to tell how many text messages can you send. Okay, so this each right here, 15 cents each is a multiply word. That tells you that the 15 cents gets the variable. So 0.15x. The total you can spend is 10, and you can spend no more than 10, which means you can't spend 11. Hey, but you can spend 10 or less than 10, but you can spend up to 10. All right, so to solve this, I divide by 0.15. There's no flip because I divided by positive 0.15. And I don't know what that is. Let's put that in the calculator. 10 divided by 0.15 is 66 and 2/3, or 66.6 repeating. So can you send 2/3 of a text message? No, that doesn't make sense. It rounds to 67, but you don't have enough money for 67. So we would go with X is less than or equal to 66 text messages. So I could send 10, or I could send 25, or I could send 66, but that's the most I could send with $10. And again, that's an old question. It doesn't cost, however many cents to send text messages anymore. Okay, so we're all finished. Go ahead and get into big ideas. Or actually, no big ideas this time. We have a worksheet. So go to assignment, and the worksheet will be there, and you'll do that worksheet on a piece of paper. So have a good day. Bye-bye.